هلا we will begin our study of the motion in the Cartesian system x, o, y, and we'll begin with the position vector. So first, I want to mention that any object studied here in physics in this lesson will be modeled by a point object, and this is to simplify our study. And if you have, for example, a car that's moving, a cat that's moving, any object will model it by will assimilate it to a particle and model it by a point object. So what do you mean by the position of the object and how to determine the position of an object at a certain instant? This will be our first step in order to study the motion and then to study the velocity and the acceleration. So first, let's suppose you have here, for example, a cat that's moving along a curvilinear trajectory. If we want to study the position of this object at, for example, instant t0 or at instant t1, we must have first a certain system. We can't study the position at without having a system. So لنفترض for example جينا طلعنا على هيدي الكات من فوق وبدنا نحدد position لها. So for example here, this is the object that's moving. Then in this case, in order to determine its position, we must have a certain system. So أول part, we trace the system اللي هو x o y system in this part واللي هو عنده two vector unit vector I and j. And then we notice that this object is moving. So now بدي أعرف the position of this object, for example, at t0, its position at t1, its position at t2. So what do you mean by position on the graph? A position vector as definition is the vector joining the origin of the axis to the particle m at the considered system. So لكن ما ننتبه انه joining the origin على طول بالposition vector بدي ارجع على origin of the axis of the system, and this is why the first على طول لازم يكون في عندي a system. So the system here, it's x o y system, the origin is o. So when we say now the position of m at t0, then it's the line joining, or it's the vector joining o to the point, to the object. Then here it will be om0. Now the position of m, so this object is moving at t1, then it will be om1 vector. At t2, then it will be om2 vector. So بدنا ننتبه انه the position is a vector. A vector means it's having four characteristic: point of application اللي هي ال O, line of action om0, direction, it's along from O to m0, and the value, now we'll see how to find the value om0. So the position vector لكن is noted RT in physics as symbol, and it's equals to OM. It's given by, so R vector is equals to OM equal XI plus YJ. So if we notice in the in this figure, the position of this object, it has x and it has y as coordinate. So in order to determine its position exactly, we need to have x and y, and in this case the vector will become om0 equal xi plus yj. Now how to calculate the value of this vector? In order to calculate its value, r equal om equal radical x square plus y square, just as mentioned in the math part اللي هو scalar and vector. Now as remark, want to pay attention that x and y are called the parametric equations, since these are equations depending on the time. This means if we notice each time the object is moving, the x is changing and y is changing. So x is changing with respect to time, and y also is changing with respect to time. This is why x and y are called parametric equation depending on the time. Now example, let's suppose for example at t0 the coordinates of this point is 0.5 and 1.5. Then in order to write the position vector, r0 vector is equal to om0 vector equal 0.5i xi plus yj 1.5j. Now its value is equals to om equal radical, you have x, and you have y, and then we can calculate the value in SI unit. It will be 1.58. Now if we return to the figure اللي هي the cat that's moving, so here أنا عم بشتغل in space, so كمان is the same thing, nothing will change. So first step, in order to determine a position, we need first to have an axis. So this is the axis XOY system. It's the XOY system. Second, بعد ما حطينا الأكسس, now but the position. So the position at T0 is OM0. At T1 it's OM1. At T2 it's OM2, and etc. So it's a vector joining the origin to the object that's moving, which here is the cat. Now how to determine, for example, OM1 as vector? So it's determined by its coordinates. x1, for example, here equals to 2, and y1, for example, 2.5. Then in this case, r1 will be equal to OM1 equal x1i plus 1 y1j. Now, so it will be equal. We have x, we have y, we can substitute. This is for the vector. Now how to calculate the value? So the value is equals to radical x square plus y square. هيك بنكون شو عملنا؟ طلعنا ال x and y, يعني the exactly position of the cat at T1, and plus كمان طلعنا ال value of OM1, يعني المسافة من ال O لعند ال M1 قد ايه بتساوي. Position vector of a ball in motion. So here we'll take another example. It's the motion of a ball. So the question is, we want to determine the position of this ball during its motion at each instant. Now first, in order to determine a position, we must pay attention. Then we can define a position in terms of scalar, in terms only of value. Since if we set, for example, the position of the ball at the time t equals to 0 is, for example, 2 meter. على اعتبار انه كان ماسكها هون للطابة وعلوه عن الارض طوله فوق شوي، so اعتبرنا انه علوه عن الارض is 2 meter. So if you have, for example, a person and you tell this person the position of the ball is 2 meter. If you set 2 meter, then in this case it's not a determined position, since 2 meter can be 2 meter upward, it can be 2 meter to the right, 2 meter to the left. So in order to determine a position exactly, we need a direction. When we say we need a direction, then this is the characteristic of a vector. So هون رجعنا انه we want to use a vector. So the position, مع انه انا عم بقول بدي direction, the characteristic of a vector is the direction. It's not a scalar quantity, so it's a vector quantity. This is why we say we position vector. Now in order also to determine the position, we need a fixed axis, we need a fixed system, reference. So in this case we are using now the system اللي هو x or y, so we'll take the x or y system as reference. And O will be, so here like we have the ball that's moving, we've taken many points at t equals to 0, at t equal to 4, at t equal to 10, t equal to 13, and then we will, first step, in order to determine the position vector, we must have an axis. After tracing the x or y axis system, so in this case we have the direction along x, we have the direction along y, I and j, then in this case we can determine a position vector. Now if we want to determine the position vector at t0, هلا صار فينا نقول that the position vector, it's the vector joining from the origin and to the point m0, which will be in this case OM0. So this will be the position vector. If we want to write it in terms of vector, بما it's a vector, so we notice that it's along it's along the y-axis. Then this means it's along a j. So OM0 equals to 2j, since we said that this height is equals to 2 meter. So we'll obtain OM0 equal to j. Same thing if, for example, we want to take at the point M10. So at this point, if we want to determine the position, لنفترض for example انه الطابة لما وصلت على هيدا البوينت كانت تحركت to the right 2 meter and طلعت لفوق 2 meter, فبيطلع عندي 2 meter and 2 meter upward, so بيطلع عنا this height كلها equals to 4 meter. Then in this case, in order to determine the position vector at the point M10, then it will be 2 along x and 4 along y, then this position vector it's OM10, so على طول برجع للreference للorigin, then OM10 such that OM10 is written is of the form OM10 equal 2i plus 4j, 2 on the x-axis, 4 on the y-axis. Now how to determine the value of these vectors? Since it's a vector of the form xi plus yj, then we knew in the part before that in order to determine the value we use radical. So OM10 will be equal to radical 2 square plus 4 square equal to radical 20 meter. Same thing for OM0. In order to find the value, so OM0 equal radical y square, then it will be, since x equals to 0, then it will be equal to 2 meter. And هيك بنكون عبينا عن position a vector at the point M0 of the ball and the position vector at the point M10. We can also find the different position vector of the ball at different instants.